Okay, this is still section 5.4, and we're going to look specifically at the division of the rational expressions now. And with division, there are some stricter restrictions. And the one thing I'm going to mention right away, whenever you have a division question, it doesn't matter in your second expression here, and when you factor out your restrictions, you cannot have x equaling 0 in the denominator, which is the same as multiplication. But whenever you have a division second expression like this, called a divisor like this, it also goes to say that you cannot have 0 in the top either, because that would make this 0, and then you'd be dividing by 0, which is making it undefined. So your restrictions for division, you have to check all your divisors, numerators, as well as their denominators. Okay, so we'll look at that when we work on. So the first step is always to factor first. So this is a difference of squares, x plus 3 and x minus 3. And this would be x, okay, we got to multiply to 4 and add to 5, x plus 4 and x plus 1. And dividing, I'm going to keep it as dividing for now. And this would be x minus 3 and x minus 1. And here we have as well x plus 4 and x minus, or sorry, not minus, plus 1. Okay, so we can do our restrictions from here. So our restrictions will come from these two, and these two. So x cannot equal negative 4 from that one. X cannot equal negative 1 from that one. These are the same here. Negative 4 and negative 1, so we don't have to repeat them. And x cannot equal positive 3, and x cannot equal positive 1. So there's our 4 restrictions in this case. So now, in order to reduce, we have to multiply by the reciprocal. So I'm just going to rewrite this. Times, or dot if you like, and then x plus 4 times x plus 1 over x minus 3 and x minus 1. Okay, so if we do our cancellations here, that would cancel that one, this would cancel this one, and one of these will get canceled out. So our answer is x plus 3 over x minus 1, with the restrictions that x cannot equal negative 1, negative 4, 1, and 3. Just going to put them like that. Okay, and that's an example of division. And noticing that restrictions are much more difficult to do in that case. Okay, I have another example that I'd like to do with division here, and I'm just going to flip over my page. Okay, here's another example here. Okay, so let's factor this one as well. Okay, noticing here that this one has the use of common factors in it. So there's a common factor here on the top of 2. So take it right out. So that's x squared minus 7x plus 12. And there's also a common factor here of 4. So that's x squared minus, 4 into 64 would be 16. Okay, divided by, no common factors here. Could have factored that out, but we'll wait till next step. Here we have to use decomposition, and if we remember back in our tutorial on multiplication, I used the same one in there, except this is minus this time. So it has to add to multiply to 10 and add to negative 11. So that'd be negative 10 and negative 1. So we can use that decomposition. Minus 10x minus x plus 5. So if I were to, I'm just going to do the decomposition right out here right now so that we can take out the common factor of 2x here. So that would be, in this case, x minus 5. So we want this to be negative, so put a negative there and we get x minus 5. So now we have everything there. Now we can do our factoring underneath. So 2 here, two numbers that multiply to 12 and add to 7. Okay, that'd be 4 and 3, both negative. Okay, and this is a difference of squares. So x plus 4x minus 4. Dividing here, multiply to 15 and add to negative 8. That would be x minus 5 and x minus 3. And then here we have 2x minus 1 times x minus 5. Now is the time to apply our restrictions. Remember with divisions that the numerators and the denominators cannot equal 0. And just over here, just the denominators cannot equal 0. So let's do this part here first. X cannot equal 4. X cannot equal negative 4 from those two. And let's do the numerators in the division part. X cannot equal 5. X cannot equal 3. And let's do the denominators now. X cannot equal 1/2. Okay, if you bring that over there. And x cannot equal 5. So there's 6 restrictions there. There they are. So now let's do our canceling. Well, we can take a 2 out here and 2 out there, leave a 2 on the bottom. Negative 4 and negative 4. Here we have a negative 5 and a negative 5. And what we're left with then is x minus 3. Oop, I made a mistake. I forgot here to do the reciprocal first. So let's ignore my canceling there right now. What would I have? And let's do back here. I'm going to move that up. Because this is division, not multiplication, I have to take the reciprocal of this first. So let's go back to this step before I started canceling erroneously there. I apologize. And let's say I still had this. But I must change it to multiplying, and I put this on top. That would change things a little bit, I'm sure. You know, I apologize again. So I should have done the reciprocal here. So ignore the canceling in that step and do it here. Okay, my mistake. Just don't want to redo everything here. Just make sure we're still in the field of view here. Okay, now the restrictions are still correct, but we still had to just flip this over. Then cancel. Don't cancel up here. Ignore that. So obviously I'm still going to get, in this case, I'm still going to have this cancellation here, where I have a 2 here. And I'm still going to get this cancellation here, but I'm going to get this one and this one as well. So it's going to end up being 2x minus 1 all over 2 times x plus 4. And my restrictions apply. X cannot equal, in our case, 1/2, 5, 3, 4 and negative 4. Apologize for my error, but hopefully that will still be okay. In our next tutorial, we're going to look specifically at combining, multiplying, and dividing together in some more complex examples of this and finding restrictions of that as well.